out of our basic derivative rules, power rule is definitely the one that can help us take the most derivatives. It's the most useful. It's very, very powerful. However, in order for you to use power rule, you have to set yourself up in order to take the derivative of even complicated functions. You have to turn the function into a sum or difference of powers. So, although this derivative seems complicated, it can be simplified, but you can't take the derivative yet. You have to make this a sum of powers. You don't know how to, you can't simply take the derivative of this one and multiply it times the derivative of this one. That is not a derivative rule. So we can expand and simplify this function to create a sum and difference of powers. I won't write f prime at x yet because I'm not taking the derivative. I'm simply changing what the original function looks like by expanding. So 3x times 2x squared is 6x cubed. 3x times negative 4x is minus 12x squared. Then we get positive 3x minus 2x squared plus 4x minus 1. We can simplify that to get 6x cubed minus 14x squared plus 7x minus 1. And so that is still f at x. Now I'm ready to take the derivative because it's a sum of powers or difference of powers. So f prime of x, let's use power rule. Power rule says take the exponent and multiply it by the coefficient out front, then subtract 1 off the exponent. So 3 times 6 is 18. This goes down to x to the 2. Take 2, multiply it by negative 14, and you get minus 28. Subtract 1 off the exponent, and you get x to the 1. Remember the derivative of 7x, the x just goes away, so it becomes plus 7. And the derivative of any constant by constant rule is just 0. So this is our derivative. Similarly for this one, you can't take the derivative of the inside and just square it. That is not a rule. You have to turn this into the sum or difference of powers. So we'll do that by squaring the binomial. Squaring 4, we get 16. You double the product, you get minus 8x, and then you square the last. You get plus 4x squared. Now we're ready to take the derivative. The derivative of any constant is just 0, so the 16 is gone. The derivative of negative 8x is just negative 8. And the derivative of 4x squared is positive 8x. So that's the derivative. This seems even more complicated, but we can simplify this by splitting the denominator. Whenever you have a monomial denominator, you can split each term in the numerator to be over top of that denominator. So we'll change it to look like this. X squared over x squared minus 2x over x squared plus the square root of x over x squared. We still don't have a sum and difference of powers. We have to simplify each term before we can use power rule. So x squared over x squared is just 1. Minus 2x over x squared. By exponent laws, you can subtract the exponents. So you get minus 2x to the negative 1. We can do the same thing here. This root x is the same as x to the 1/2. So imagine x to the 1/2 over x to the 2. What you would do is subtract exponents. So you get plus x to the negative 3 over 2. Now that you have a sum and difference of powers, you can take the derivative. The derivative of 1 is just 0. The derivative of negative 2x to the negative 1. You take the exponent, you multiply it to the number out front, and then you take 1 off the exponent. Minus 1 minus another 1 is negative 2. Here, we can take this exponent, multiply it to the number out front, so you get minus 3 over 2. Again, write fractions like this and put the x in the middle. And we subtract 1 off the exponent to be negative 5 over 2. That's the derivative of this function.